So welcome all. Today we are learning something about how can we improve the performance of our system. When we are talking about this topic, we are considering only the single system application or organization. So to improve the system performance, what we can do is we can enhance certain portion of the system. Now the question is, in your system, if at all we have several different portions, should we improve all the portions or some of them? So what actually we say, one law is, we call it Amdhal's law. What does it say? It says that we have to make common case fast. Okay, common case means frequent case. Okay, those part of your system which are being used frequently, I should say most frequently, they should be enhanced within the cost and price limit. Okay, within the cost and price limit means you can understand about cost and price. See, cost is your manufacturing cost, and price is your market price. Okay, so suppose whatever your cost was earlier, maybe suppose in market the same system is available at $100. Okay, and after enhancement your cost has raised, certainly price will also go up. Okay, so what happened? Your okay, let me give you example. Your now you can sell it in how many dollars? Suppose $1,000, maybe $150 or $200. So now you can see that your cost is high. Now it is higher than the price available in the market. So this enhancement is not of that use. Okay. However, if you will be able to sell something in $90, in market it is of $100, in that case this enhancement, this particular enhancement is helpful. So we have also to keep this thing in mind, that the enhancement should be in the limit of our cost and price. So in what Amdhal's law says, we have to make the common case fast. When we talk about making common case fast, what does it mean? Suppose our system, in our system maybe there is some part, maybe floating point operation, which is frequently being used. Okay, which is frequently being used. Suppose frequent use means suppose 90% of the times this particular part of the system is being used, and some part can be considered as a rare case. Okay, it is rarely being used, rest of the system. Okay, suppose it is a floating point operation, or it is something integer operation. So if we make this part enhanced, then it will improve the system very potentially. Okay, so the Amdhal's law says that you have to improve the frequent case. So before enhancement, you should analyze the system in I should say two views, one in common case and second is the rare case. So you have to improve the common case to increase the performance. You also understand, we have already seen what is performance, how speed up is calculated. So suppose the system before enhancement and after enhancement you have, then you can find the speed up. Okay, what will be the speed up? The speed up will be something like performance of new system upon performance of old system. Isn't it? So old system is the one system without enhancement and new system is the system with enhancement. And as we are talking about the single system this thing organization, in this case this thing performance will be inversely proportional to execution time. So what will be here? It is something it will be 1 upon execution time of the new system upon 1 upon execution time of old system, right? It can be understood as execution time of old system upon execution time of new system, isn't it? So we should also understand that the execution time, this execution time of the new system will be less than execution time of old system. Why? Because we have enhanced the system, right? So if this is there, then only we can say that enhancement has been taken place. Okay, now you have to calculate the execution time of the new system. So it will be dependent on two factors. Okay, what are the two factors? The fraction enhancement and the speed up enhancement. Okay, so let me tell you, it will depend on two things. One is the fraction enhancement okay, let me name it as F. What is it? It states how much portion of a particular old system undergoes enhancement. Okay, and the second thing is a speed up enhancement. Speed up enhancement, what is it? Enhancement. Okay, so it states how much faster the task is running with this particular enhancement. Let me take it as S. So in case of fraction enhancement, you can understand that F, if at all F is the fraction under which undergoes the enhancement, then the total is 1. So F is a portion of 1. It may be 0.5, 0.2, 0.6 or 0.9 kind of thing, right? So total, if you understand that unenhanced plus enhanced portion will total to 1. Now if you talk about the speed up enhancement, suppose in this case you can say speed up S will be performance of the fraction, है ना, performance of that particular fraction, है ना, in the new system and performance of the same fraction in the old system. Performance of that fraction in old system, right? So this can be understood as ET of which ET? Fraction ET, yeah? Fraction ET, not the whole system. Fraction ET in the old upon execution time of the fraction in the new system. Okay, so it can be also written as ET, I should say ET old for this fraction, and this is ET new for this fraction. No problem, same thing. So now let me understand the ET new for the whole system. Okay, what it can be? Let us calculate ET new for the whole system. It will be execution time for the both the portion, unenhanced portion as well as enhanced portion. Unenhanced portion, let me write unenhanced portion plus enhanced portion. So execution time of these things. So what it can be? Execution time means ET old, suppose, है ना? Unenhanced portion and enhanced portion. So unenhanced portion is 1 minus f, the same old time, plus the enhanced portion. Enhanced portion is, what can be the enhanced portion? It will be ET old f upon s. Will it be or not? It was s, है ना? So in this case, from here you can find that if you want to find the ET new, it will be ET new fraction is ET old fraction upon s. Is it? So same thing we are keeping here. Let me not keep this thing. Okay, so what is happening? ET old with this fraction plus ET old of this fraction upon s. No problem. So now what happens? ET old, you can take this ET old common here, so it will be ET old. Okay, you can keep 1 minus f plus f upon s. Okay, so this is something about ET new. Now you can calculate the ET new based on the values of the ET old and the speed up with the new fraction. Okay, so overall speed up if you have to calculate for the system, this is speed up. We are calculating overall speed up. Overall speed up will be means the speed up of the whole system. So it will be ET old upon ET new, right? So this will be ET old upon ET new is this particular thing, है ना? It is ET old into 1 minus f plus f upon s. Okay, so it can be considered as 1 upon 1 plus f upon s, is it? So given a system where you have enhanced some portion f, it can be 0.5, 0.6, 0.9 or 0.2, whatever, and you also have the information of its speed up, how much faster the particular fraction has become, then you can find the overall speed up of the system using this formula. This is not plus, this is minus, so 1 minus f plus f upon s. This is the speed up of your system. Now this is the case when there was only one enhancement. What will be the scene if there are multiple enhancement? Okay, suppose you have multiple enhancement. If you have multiple enhancement, what will happen? In that case, your speed up will be, here you have to understand that in place of one f upon s, you will have multiple f upon s, right? Suppose one portion of which is 0.2%, this thing 0.2 means 20% frequent, means 20% being used, 30% being used. So these are two portions being enhanced. So there will be this 0.2 upon its speed up, 0.3 upon its speed up, and here you will have to subtract 1 minus 0.2 plus 0.3 is 0.5. So 1 minus 0.5. So similarly, if you want to generalize, you can write it as 1 minus summation of all the fractions. Okay, fi, है ना? This is okay 1 upon plus there will be summation of all these, summation of all fi upon si. Is it simple and fair? So this is how you will do. Suppose you have two enhancement for, okay, let me write for two enhancement. For two enhancement, what will happen? The formula will be 1 upon, speed up is equal to 1 upon 1 minus f1 plus f2, right? Plus summation of this thing. So it is f1 upon s1 plus f2 upon s2, right? That is what, very simple, this thing for multiple enhancement. So in this way you can find out if at all what is happening. If there are enhancement in your system, what will be the speed up, and using these formulas you will be able to find out one thing, given the another, right? Sometimes speed up might be given, one of the fraction can be given, and you will have to find the other fraction, or sometimes fractions will be given, you will have to find a speed up. Sometimes these other information related to execution time may be given, and you will have to find out the other things. So you will have to keep these things in mind. So this was something we were seeing here in this case of how to improve the system. As far as CPU time calculation is concerned, we will see some more things in CPU time calculation. How a program can be a sequence of instruction. So based on the instruction and the cycle time, we will have to consider how the CPU time is calculated. And it may be the CPU time can be calculated based on the cycle time given. If at all, sometimes cycle time may not be given, throughput might be given, that number of cycles, the rate can be given, that this how many instructions are executing per unit time. So then you can also calculate the CPU time. So we will see this thing in next video. For now, thank you.